This video continues from the Welcome to Clear SCADA video, which introduced general Clear SCADA concepts and showed how to create your first configuration. In this video, I will show you how to configure Clear SCADA to communicate with a DMP3 RTU to retrieve timestamp data. To start, ensure that you have your Clear SCADA database running, Vuex open, and you are logged into the system. In my case, I am logged in using the user called eng. Communicating with the DMP3 device requires a number of objects to be created in the database. Let's begin by creating a folder to hold our configuration. We'll call this folder DMP3 Tutorial. The first object to create is a DMP3 direct channel. The channel object relates to the communications mechanisms used by Clear SCADA to communicate with the device. For example, this may tell Clear SCADA to use a serial connection or connect via UDP or TCP. Call the channel Channel. Double-click on the channel to open the Properties form. Tick the In-Service box to make the channel active. Go to the Connection tab, change the connection type to Network and the TCP IP type to UDP. You may need to change this part of the configuration depending on the setup of your DMP3 device. To allow the DMP3 device to send unsolicited messages or report by exception, we will enable the Listen port and set it to 20,000. This is the port that the remote device will send its messages to, and so this is the port we should listen on. Lastly, on the Scan Parameters tab, set the line speed to 1024000. Clear SCADA uses this when calculating response timeouts for communications. Save the channel configuration and close the form. The next object we need to create is called an outstation set. This defines a group of RTUs, or outstations as we call them in Clear SCADA. Create a DMP3 direct outstation set in the DMP3 tutorial group. Let's call it Set. Open the Properties form. On the Outstation Set tab, put the set in service and tie it to the channel we created. The easiest way to do this is to click on the Browse button here and select it from the navigator. Click on the DMP3 tab and set the local address to 30,000. This is the DMP3 address of Clear SCADA, meaning the DMP3 address that Clear SCADA uses to communicate on the network. Save the form and close it. And finally, to establish comms to the device, we need an outstation object. So let's create a DMP3 direct outstation object in our DMP3 tutorial group. Open the Properties form and start with the Outstation tab. Put the outstation in service. This will allow Clear SCADA to attempt to communicate with the device. Tie the outstation to the outstation set, which is in turn tied to the comms channel. Again, you can use the Browse button here. Go to the DMP3 tab. There are a few basic settings here we will configure. Now don't worry too much about the number of settings here. The DMP3 protocol is very configurable, but in most cases the default values will work just fine. Detailed information can be found in the online help for each field by pressing F1 or by reading the tooltips provided for each field by hovering over that field. Set the address field to 1. This is the DMP3 address of the remote device. Set the integrity polling interval to 10 seconds. You can do this by entering 10S. This asks Clear SCADA to interrogate the device for both timestamped event and current or static data every 10 seconds. Finally, go to the Network tab. Select Single Network from the Network drop-down. Enter the IP address of the device, in my case 192.168.2.3. The port field here is the port on which the RTU is listening for inbound communications. In my case, this is 20,000. Now save the form. That's all that's needed to establish comms. We can see if we were successful by looking at the status dialog for the outstation object. In the Database Navigator, right-click on the outstation object and select View Status. Note that the state field says Healthy Multidrop. This tells us that Clear SCADA is successfully communicating with the device. Finally, we add some points to retrieve data from the device. My device has two analog input points configured. The first, at address 1, is a sine wave input with values 0 to 100. All the data is recorded in the RTU every 2 seconds and returned to the master, in this case Clear SCADA, when requested. The second point at address 2 is a sawtooth input that moves between 0 and 10,000. This input updates every 2 seconds. However, unlike the first point, when it updates, the information is immediately sent to the master in an unsolicited message. So let's configure the points. Create a DNP3 analog input point in the DNP3 tutorial folder and call it AI1. Open the Properties form, put the point in service, and tie it to our outstation object. Set the point address to be 1. Scroll down to the scaling section and untick the enabled option. The values returned from the device for point 1 require no scaling. Go to the Historic tab and enable historic logging of data for this point by ticking Enabled. Set the offset to h-1h and the interval to 2h. This will default the trend time span to start from the beginning of the last hour with a span of 2 hours. Finally, tick the Use Raw Data box at the bottom. This tells Clear SCADA to display trends using the raw samples rather than processing the data prior to sending it to the client. Save and close the form. We can check that the value is updating by checking the View Status dialog for the point. You can see the point value updating after each 10-second poll as we hit the refresh button. Create another DNP3 analog input point, and this time call it AI2. Again, put the point in service and tie it to our outstation object. Set the point address this time to be 2. Go to the Historic tab and enable historic logging of data. Set the offset to h-1h and the interval to 2h and tick the Use Raw Data box at the bottom. There are a couple of minor differences for this point. We want to take our 0 to 10,000 input and scale this 0 to 100%. On the Analog Point tab, note that the 0 scale and full scale are already 0 and 100. Now we just need to set the raw values. Scroll down to the Scaling section, enable it, and set the raw full scale to 10,000. Set the units to %. We are now complete, so save the form and close it. Again, we can check the updates using the View Status dialog, and this time note that the values are updating much more quickly as the remote device is sending changes as they occur, using unsolicited messages. Finally, we can add these points to a mimic to more easily view the data. Open the default mimic in design mode. Drag on the AI1 point and show its name. Also show its formatted value and last updated timestamp. Then we do the same for the AI2 point. Lastly, we drag on the outstation object to show its status by selecting the State option. And now we can tidy up the mimic. So let's save it and put it into run mode. Open up the historic trend for AI1 and AI2 from the object menus, and then tile the screen to view both trends and the mimic. From the historic trends of each point, you can see that the points are updating. AI1 every 10 seconds when Clear SCADA pulls the device, and AI2 every 2 seconds as the device sends through another message. And before we finish, let's have a look at what happens when communications is lost to the device. Unplug the comms cable from the device. After some time, Clear SCADA will raise a communications failed alarm. The time to raise this alarm depends on how frequently you poll the device, the comm retries configured, the number of transaction attempts, and the way that the failure occurs. All these settings are configurable to provide flexibility in the way that comms problems are reported to users. Notice the comms failure alarm in the alarm banner and on the Mimic, and the fact that the points on the Mimic now show as purple. This indicates bad quality, and we can see from the View Status dialog that the quality is last known value. After a short period, we plug the comms cable back in. Pay attention to the trends. You will see that because the data is being stored in the RTU, we haven't lost data. Everything that occurred is transferred to Clear SCADA when the comms is re-established. The history is maintained, and the user has a record of the comms failure in the event journal for future analysis. This is one of the key benefits of DMP3 in that a comms failure does not mean a loss of critical process data, billing information, or data mandated for regulatory compliance. This brings us to the end of our DMP3 tutorial. While DMP3 provides significant flexibility, it's possible to configure and deploy simple systems quickly and easily. Clear SCADA provides a number of tools to simplify the configuration, deployment, and management of DMP3 networks, and you can find information on these tools in the Clear SCADA online help. Tools such as templates and instances for configuration, driver log translators for COM diagnostics, and advanced capabilities for multiple comms paths, backup dial links, configuration downloads to SCADAPAC E-Series RTUs, and more, make Clear SCADA the leading product for SCADA and wide area telemetry systems. Thank you.